Hello, hello. Okay, so welcome to the Machine Engine channel. We're gonna be building this better version of an RC car today. I'm Pedro, by the way. Yeah, we're still working on our camera setup. Where new camera is on the way. We just started with what we had, so we just had a laptop. Since I could switch to this mode, but this camera this kind of lags, so we'll use it sparingly. But yeah, this is basically the RC car we're gonna build. I'm doing the hardware now, just kind of assembling it. I mean, you have the steering column. This way you can steer the car, and we have this. This is the drivetrain. I mean, you got your huge gear right here. It's like really simple stuff. And we have these like metal strips that we use to like kind of we screw them together. They have like these holes, and we cut them at different lengths. You know, like the old Meccano thing. That's kind of like what we did. It's like this big roll that we could buy, and we just cut them up at different sizes. So we can just do that. Assemble. You can like pretty much like, you know, put them in different configurations. If you have screws, we have some screws and you know, some bolts and nuts here, so that we can you know, so that we can like just bolt these together. Pretty handy for these kind of like quick thingies, quick builds. Works really well. It's not like a permanent thing. I mean, we use these to like just kind of like prototype things kind of fast. If we need like some kind of, yeah, I mean, because you can like bend them too, so you can make like a 90-degree angle, and you can like make like a table. So it's pretty handy to like kind of, if you need just like a square thing or like a chassis or something really quickly. I mean, it's better than like it's way faster than like having to 3D print it or something like that. It works really well. Bend them at 90-degree angles, make a table, you know, that kind of stuff. Make a box. You can do, but right now we're not gonna bend them. We're just gonna use a flat. We're using them as the chassis for the RC car. So we're gonna, yeah. We're just gonna lay them down. I already kind of laid them out in their the configuration we're thinking of using. We have different parts. I mean, we got the motor here. This is gonna go like this on this. We got a 3D. We have some 3D printed parts, and these metal strips. I mean, this steering column is 3D printed. I mean, we could have done it in a CNC, but it took like 5 minutes to 3D print, so we're like, whatever. It's all good. But you could have done it in a CNC machine. Well, not a CNC, I mean the laser cutter. We have a laser cutter over here, but CNC is it's a bit overkill, but the laser cutter could have done it. But yeah, that works. This we could have definitely done it on the laser cutter, but we did it 3D print because you're like, it's whatever, lazy. We were kind of yeah, it's kind of expensive to do this on a 3D printer. Don't do it like that. But yeah, whatever. This is we're gonna put the Arduino on this. It's gonna be running on an Arduino, and then we're gonna go through via the Wi-Fi and control it through our mobile phone using Machine Engine. But yeah, more on that later. Right now we're just gonna build the thing. So yeah, I gotta start with this. Attaching the steering column to these strips. I use the smaller bolts. So just pass it through. Put it on the other side. There you go. A little loose for now, just to get it there in position. Gonna tighten it up later. Just to get it into position. Yep. So that's that. Just a little loose for now. Gonna tighten everything up later when we like have the shape done. Only 2 screws because maybe if you can see it, it can. We have 2 screws, but actually it can kind of interfere with the steering a bit, so we're just leaving it at 1. But it's enough to drive the whole thing. Then on the other side, we do the back.
Also, one reason why we made it a little bit thicker at the end is because the motor could not fit if we had the smaller one. So as you can see here, it doesn't fit. So we had to, let's say, make it have a bigger ass, let's say, in order to make the motor fit.
Yep. Yeah, exactly. There were some design issues. I mean, we're just basically winging it with this design. So there were some small issues with the width. But man, we solved those. That doesn't really matter that much. It's all fine.
And yes, of course, don't you like a car with a bigger ass? What is it? Cyberpunk? How do you?
Yeah, he said a bigger ass.
Yeah.
What's the name? Cyberpunk. Yeah.
How do you actually
you know. He likes it, but he cannot lie, I guess.
Yeah. You cannot lie. The car needs a bigger ass.
Yeah. But yeah, it's there were some issues with the gearbox. We went through several iterations of gearboxes. So this is like the final one. And yeah, it should work way better than all the other versions. Yeah, so we got ourselves a little square or a little rectangle there. That's like the basis for the car. I mean, it's still like going in all directions, but you can just add more screws to stabilize it. Yeah, when we add this part, it's gonna stabilize it more. But right now, I'm gonna add more. You got the spacers? Can you give me that box? No, I don't have any over here. Yeah, this is good. This is good. So, yeah, let's see. So we got these holes are kind of big. So I'm gonna put a spacer in it to be able to put a bolt in there, just to get it a bit tighter. Yeah, no one can lie, right? Oh wait, I need a spacer on this side too, because the hole's kind of big, so it's you need to you know, cover it up properly. It's gonna work. Yeah, it's gonna work. It's fine. The what's this? Yeah, so you got the other size spacers?
The other size?
Yeah, there were different sizes. There were smaller ones.
But,
no, there were smaller ones. There was a whole box full of them.
Yeah, well, I think those are kind of gone. So I think we don't have them anymore.
Okay. Well, yeah, it happens that we use things and then they just suddenly disappear, like mysterious.
I think we use them a lot.
Yeah. It's like socks in the washing machine, you know. What's that say? Yeah, the spacers, we need them because some holes are bigger than others, so you need to spare. You need the yeah, well, you need them to like cover up the hole. If you can see, you see that these big holes, but you gotta, you know, cover it up. It's actually kind of. Yeah, they're not exactly intended for this kind of use, but kinda, you know, whatever. But whatever,
it works.
It works. It's actually
Can't argue with results, right?
Yeah, yeah. The intent is actually to like be able to turn the when you're screwing, so you don't damage the under part, you know, that kind of stuff. But whatever, doesn't matter. Yeah. So can you hear me all right? I mean the music. I don't know. I can't tell the volume. I didn't do a audio check before this, so I don't know if it's right. Anyways, yeah. So now next we grab this one. We put it over here. I mean we have a similar, kind of similar issue. Where's the grab this. I mean this is gonna align with these over here. So.
Maybe you also have to think about this one, right? So this one should go there. So I think
yeah,
you should keep that one.
This one goes there, but the we need the longer. Yeah, these ones. These ones are gonna go in here like that. Yeah, or anyways this side.
Space for that or not?
No, we don't need it for this one. This one goes like that. Just put the motor on it now.
Yeah, so I think I will do the electronics afterwards. So Pedro will mainly do the mechanical part, and I will just focus on adding the electronics. Maybe I can already tell you which electronics I'm going to add. So of course we have the, let's say, main DC motor. We have a nice what is it, Raspberry Pi with a motor head. This is for DC motors and stepper motors, but I also added some wires such that we can control one stepper motor. What is it? Yeah, stepper motor? No, it's called a servo. Let's see where it is. Ah, it's here. So here's a nice, let's see, which camera? Is that one also okay? Okay, so this is a servo inside a little enclosure. Can I see, Pedro? Go
Sorry.
back. So as you can see, here is a attachment. This is for steering, of course, so it should go in front like that. If you can see. So when the servo motor moves, we can actually steer. What else do we have? This one. Oh yeah, right. Yeah. So this is a stepper and servo motor head. I was going to use it. I think I could also do it without it, but it's quite easy. So I'm going to attach this one to the motor head. This is a, well, it was a power bank, but now it's actually just a battery with a handy USB. With a nice, where is it?
Give me.
Okay. So this is a battery with a USB attached. It was, so like I said, it was previously a power bank. This is for the Raspberry Pi, to power the Raspberry Pi. But we are actually going to use batteries for the motor, for the DC motor, like that. 4 batteries. I'm going to insert this in this thing. It's actually meant for 8 batteries, but what I'm going to do is just make a connection, like diagonally, such that it's effectively just a holder for 4 batteries. So yeah, that's the electronics we're going to add to the RC car.
Yeah, you're just building up the frame over here. I hope that's visible. Yeah, it looks fine. Last time we used this this phone cam thing, it lagged a bit, but now it looks like it's working fine. I mean, yeah, there's delay, you know, but it looks like it's working well. Yeah, new camera's on the way, so whatever. We'll be streaming much better next week.
So yeah, one question is why we don't use the this battery instead for the motors. So this one doesn't have enough power. So what happened was when I turned on the DC motor, the Raspberry Pi actually shut down because the drainage of the DC motor. So I think it just doesn't have enough power, this battery. And yeah, it's also really annoying if it also just turns off the Raspberry Pi. So yeah, just the batteries because of the power issue.
Yep. A lot of screws. I mean, I didn't tighten anything up yet. I'm just placing the screws. Gonna tighten it all up when this is all mounted, and we have an idea of what it looks like. Also, the motor and stuff, we need to align it, because I mean, normally you would like make a prefab gearbox, but right now we're just kind of did it kind of separated. So it's gonna go on like this. It's gonna go on normally you would have like the gearbox like perfectly aligned with like a plate holding everything in place, but yeah, it's
maybe just put the stuff in the right place, right?
Yeah. So this is kind of what it's gonna look like a bit. I mean, yeah, it's now I need to move the struts that are gonna hold it together. Move them to the side to the new position.
Also a little bit of use.
They're it's like on a board. You can see it maybe better on this camera. It's like it's board with what's it? M8. It's an M8 board. Bar. So it's gonna let us, so we can do this, and then move the ball bearings that we used, move it across, and replace them in a different position. Also, we 3D printed this holder for the ball bearings to let it rotate. So we can do this. Just turn the bolts. I mean, there's a lot of turning, but yeah, whatever. It's it works well. It works well, so just whoop, 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 whoop.
And maybe you're already going too far.
Yeah.
So do the other side?
Yeah, do the other side.
I thought maybe done.
Okay, now let's see. Let's attach it. Somebody's playing music in the back.
I think they cannot hear it. Can you guys hear the music?
They probably can't.
Yeah.
I mean, we're not alone in this factory area. Okay, so this one. Oh, that's a bit long. Oh, where are the short ones? I need more. Here we go.
So also, like, the 3D printer missed one of the holes. So this side is one hole, this one two. It doesn't really have a reason. It just happens.
Yeah, it's
sometimes you do not really get what you think you will have when you're 3D printing.
Yeah, the whole the problem is
the whole problem.
The problem with 3D printing is these non-manifold edges or whatever. The weird thing is that this one came out with one hole and this one came out with 2 holes. It's supposed to have 2 holes, but somehow it failed at the second print, and yeah, now we ended up with just 1 hole. So weird. I don't get it. Makes no sense.
Models, right?
No, it's the same model.
And this one was the second one. Or
yeah, that was the second one. So something weird happened with the print, but I was like too lazy to fix it, so I was like, whatever. I mean, we got the 1 hole, so it's fine. Yep, a lot of screws in this thing. This is the only problem with this, with these metal strips. You gotta put a lot of screws in them, but whatever. For fast prototyping, it's actually pretty good. I mean, you can do all kinds of shapes. It's kind of like Meccano, that old toy, that old assembler set. I mean, these days Meccano's kind of crap, but whatever. This one's a bit tight, so I need to use the. Whoa, this one's really. What's going on? Okay, I'll fix that later. So now slide them in position. Make sure it's all straight. And then just turn the, yeah, I don't know if you can see it, but turn the bolts to their position. This needs to be a bit more. There we go. Okay, I'll turn it around. I'm gonna do.
Really fix that thing.
Yeah, put it. This one, don't let it turn, and then like, there you go. This side, same. Just there we go. So that's fixed now.
Is it not too wide?
Oh no, it's fine.
Okay.
That's yeah. So now, see yeah. Now I'm gonna do. It's gonna I'm gonna fix all these parts properly. Let's see this. I think I'm gonna need a spacer there. Yeah. Just to be safe, put a spacer on there. It is a pretty long screw, but I'll need a. It's just to be safe, or else we're gonna get in trouble maybe.
So you also use these ones?
Yeah.
Okay.
Does that fit? It's okay.
Maybe you can also add one of these, then it's a bit wider, if that's one of your problems. You can?
Yeah.
So also do the other one?
Yeah, do the other one. So yeah, the other side. Whoop, dropped it. The other side is kind of, I don't know. I don't trust it. It's a bit
small.
It's a bit, yeah. So we're gonna add a bolt and a spacer to the other side to get it just to be safe, because I mean this is yeah, see it, bolt and a spacer. Oh, let me change that. Just to be safe, bolt and a spacer. It can stops it from moving, because the hole's kind of big, so need to no, the other side.
So
the other side. Yeah, it's below, because the holes on the other side is a bit bigger than this one. So
maybe already the bolts already enough. How do you call it?
no, I don't know, but on this side the bolt's enough. On the other side, I don't know. It's a bit. I'd rather have the spacer and the bolt.
Sure.
Yeah, thanks. I will grab that one. Anybody say something? No, okay. Yeah. So yeah, okay, so that's okay, that yeah, that feels a lot better. Oh, that's really tight. That's nice.
It's also really firm on the thing.
Yep, that's good.
I hope it will not skip a beat.
Well, we don't know. We'll see. We'll see how it works out. So tighten all of this. Looks good. Yeah, it's rolling well. Yeah, it's now we're just tightening all the bolts really tight, making sure it doesn't. This one's messing with me. So grab it on the bottom, then screw it, because it's got a screw on one side. So screw it in on the other side. Yeah, not gonna break it. Yeah, there you go. Yeah, it's fine. Okay. Most of them we can do it just on one side, but sometimes you get into trouble with I don't know, somehow some bolts just don't fit exactly right, so you gotta, you know, grab them on one side, screw them in on the other side. Works well. Fixes the problem. Now, getting this properly aligned. I mean, the great thing about these metal strips is you can fairly quickly make like a prototype of something.
But the 3D print really helps with the parts.
Well, the 3D printer helps in like the finer parts.
Yeah.
Oh, I headbutted the thing.
I mean, we have already demolished so many 3D printed parts.
Oh yeah, definitely. Well, the 3D printer does help with, like, I mean, the gearbox, I mean, the gears, and also, I mean, there's no way we can. But I mean, if we would have to 3D print this whole chassis, I mean, whatever, forget about it. You know, there's not. You'll be there for hours. I mean, but this we can just saw. We have like this. We bought like this roll of these strips. It comes in rolls. It's like 35-meter roll. It's really heavy.
Yeah.
But we built this like dispenser for it that we can easily saw out a piece with no problem at all. And yeah, it works out. It worked out real well. It's great. And then we can just build these shapes out of it. Oh, it's looking pretty good.
Yeah, it's nice.
Yeah.
It's really firm. Nice.
Yeah, it's pretty firm. It's you know, okay. It's not skipping. At least I don't feel. I mean, we'll see how it works with the power on. But yeah.
These are not yet done.
No, these are.
Good.
No, they're not good. Yeah, but if you're gonna screw it, you need to
maybe
grab.
do you think it will be faster if we do teamwork or not? No, probably not.
No, probably not.
No, here you go.
Here you go, thanks. Yeah, these ones I put them because I put these. Check it out. All the other ones. I mean, all these ones are like this, but I put these ones like this because I'm gonna put the whole raspberry thing over it. So I didn't want to mess with it. But this one is like this because we had a problem with the holes on the other side. So yeah, you know, you have to make choices on which side you're gonna put the bolts and or the tops of the nuts. You know, so you gotta make a choice on that depending on the build. I'm just gonna flip it over and yeah, just tighten it up real well. Just getting these last parts in there. I mean, yeah. Don't even have to worry about breaking anything. I mean, this is all like really hard metal, so like who cares? You just flip it around. You just tighten it up. That's pretty tight.
Yeah, we can always tighten up later.
Yeah. Now this. Also, I turned this is on this side too. The bolts. I mean the nuts on this side. Because on this side you have the moving part, so I was kind of worried that having a nut there would like interfere with the movement. It would get stuck on it, so that's why I chose to put it on this side. You know, yeah. I mean, yeah. That, like I said there, you gotta make choices on where to put your things. Now just.
Of course, not make it too tight. The moving part can also move anymore.
Yeah. Well, these parts are not supposed to move at all, so just making them as tight as possible. But yeah, the moving parts, they're not supposed to, you know, be stuck. Anybody? No. Yeah. Just, I think this is the last one. Yeah, that's pretty good. It's
so
pretty straight.
Nice, yeah. So this is like the chassis, right? Something like
this is chassis. Yeah. Put this back on there. Change the camera a bit. Yep. Okay, well, that was pretty quick.
Yeah. So you think? Oh yeah. Well, of course, you also have to add this one, right?
Yeah. So this is like the last part.
We're gonna put the Raspberry Pi on it. It's like kind of the base.
Yeah, here this is where where the Raspberry Pi goes on. These holes are for the Pi, you know.
Yeah, but we don't really use it.
Yeah.
Yeah.
So we 3D printed it with some holes. Can go right through it. I mean, it's overkill to make this with a 3D printer, but what are you gonna? We were actually testing to see how it goes. I mean, it's not like we're gonna do it all the time with a 3D printer. We were just it was a test case. Put the tall one there. Pass it through. Put this nut over here. Sometimes it's tough to get these things in there. There you go. There you go. Just spin it down. Do the other side the same. There you go. Pretty much using these tall nuts and bolts as spacers, because it's not only the Raspberry Pi, we're also putting the batteries in. So the batteries go on the bottom, and the Raspberry Pi on top. You know. I'm gonna tighten that up a bit. Get it real tight. Yeah, that's good. Get it down. This one's not doing it. It's not going well. So just gonna grab it on this side and then screw it in. I'm left-handed, so this is hard.
Stop being
Yeah. Yeah, man. Okay, those are tight. So I mean, you're thinking. Now you put the thing on there, and then what happens? it falls to the bottom. What are you gonna do? Yeah, well, you solve it like this.
Oh yeah.
You know, it's like, oh no, it didn't work. No, it does work. You just chill out. You put that there. You stop.
Put this one.
Yeah, this one goes on the bottom, the battery pack. But right now we're gonna do this one. You stop halfway. You go to the other side. You got the same. You stop halfway, and then voila! It doesn't stop. It doesn't drop to the bottom. I need a bit more space. There you go, to get the screw in there, and then just screw it. Yeah, exactly. Screw it on the top. Whoop. Oh, these are hard to get in. Yeah, there we go. Tighten it up. I mean, this is a pretty quick build, so I mean, it's not the prettiest looking car, but we're pretty confident it's gonna work.
What's the aspect ratio between the two?
It's 1 to 3. Well, aspect, I mean the gear ratio, but it's 1 to 3. So it should be, yeah, I mean I researched the gears, so it should work well. I think that's it, right? Not sure. I wonder if we can get away with the strip here.
If it's shorter, then for sure.
Ah, oh wow, it's the magnets of the thing grabbing it.
Yeah. It's rotating. What do you think?
You can probably get away with it. I mean, it adds a bit more stability, I guess.
Doesn't? Do you think it will not touch the cogs?
Yeah, we're wondering if we could put a strip in the back here.
I think it will be fine, right? Should we maybe cut another one like that? I can cut one. Or you can cut one.
I think we can just use this one.
Yeah, but I mean, we have to use a lot of screws again.
Oh, that's true.
It takes time. I don't even know we have enough. that's the only reason.
Oh, we do have enough, but I mean they're not here, but they're somewhere else. They're in the box. But yeah, I mean, not bad, I guess. I mean, it's everything spins properly.
I think we are also out of bullets.
Yeah. Well, that's it for the build, I guess. We'll just do it without it, whatever. It's fine. That's it for the build.
For the chassis build.
The chassis build. Now we're gonna
add the electronics.
Yeah. This I still need to figure out a way to like build some kind of stop here, so that the because the drivetrain kind of, well, it's not a drivetrain.
It's called just steering mechanism.
The steering mechanism kind of gets loose after a few tries because the bolts are just not like, they're not, I mean they get, because of the spinning, after a while it starts getting loose, so we'll figure that out later, whatever, doesn't really matter. I'm thinking of like making like a cap, like 3D print a little cap that I can just screw on there so that the bolts don't move anymore. You know, you can do that. Like what you have on your bike vent when you're pumping your tires, you put a cap on it so it doesn't move. Same thing. But anyways, yeah, that's it. Now Rick's gonna take it over and he's gonna put in the electronics. There we go. Yep.
Yeah, let's make a little dance, the chair dance. I can just maybe roll over there.
Yeah.
Okay. Let's get electronical. So, okay, maybe I'm just gonna repeat. Oh, hi. Okay, let's just repeat which kind of things I'm going to add. So, yeah. Yeah, live. Yeah.
Live stream.
It's barely anyone watching, so who cares? Yeah, fine. So yeah, like we said, we are going to add a DC motor. So this is the big engine for the wheels. For the steering, I'm going to use a servo motor, like that. I'm going to add it here, and then add a screw over there. So if the motor goes like when the servo motor moves, we can actually steer. Then for the power, I'm going to use a battery, which was formerly a power bank, and this is for the Raspberry Pi, by the way. And also I'm going to use batteries, and the batteries are for the DC motor because the DC motor requires more power. I put the batteries in this enclosure, but as you can see, this one holds 8 batteries, but I actually have 4, so I'm going to cheat a little bit. So when I'm inserting those batteries, I'm actually going to add a wire, like let's hold on, let's get a wire. Okay, there you go. So I'm going to use this wire. It's actually meant for trees or holding twigs together, but oh well, it works. So I have a nice wire. And I'm going to strip it. I hope we have a nice tool for it. I think we don't have a stripping tool, which is kind of annoying, but oh well, I think this will also work. Like that. It works perfectly. And the other side, hop. So now I'm going to make this one a 4 battery thing. So let's see. Okay. The power starts. Let's see. The red wire starts at this side here, and it goes like that. Wait. Yeah, and then it goes like this wire here to the other side, and that one. So here's actually one of the things we need. We need this side. Okay, so in order to make it a 4 battery pack, I'm going to add this one here, and then turn it around a little bit. Add a battery, like that. And also now the other side. Let's put the battery in place again. So here, and I'm going to add the wire there. I think this must be right. Let's follow it. Let's see. Yeah. Okay, so let's see. So it starts here, goes there, there, there. So I have to add it here. Like that. So I think this should be okay. Let's get my voltmeter. Okay. So let's see if it actually is now a 4 battery thing. So they're all 1.5 volts. So I have 4 batteries, so it should be 6 volts. Let's see if I actually did it right. So let's test it. Yes. Okay, let's show you. So if you can see, okay, let's put this one here. So now I have these 2 wires, which is of the battery pack, and if I put these ones here, you can see it goes to 5.6. It's roughly 6 volts. So this is the battery pack we're going to use for the DC motor. Just for fun, let's also just add it right away. You can see it move probably. Let's see. This is a problem, I guess. Let's see, maybe it's not powerful enough, or guys. Let's move. Come on, let's move. Let's just use some duct tape for this, because it's quite important to actually see if the gears actually have the right conversion. Duct tape. Okay. Okay, so now there were people talking around me, so I was really distracted, but they're now gone, so that's nice. Okay, so let's just see if the motor can actually be turned by these batteries. So maybe the batteries are also empty, or well, this works great. Well, great, I mean, I still need to give the kickstart, but okay, as you can see, the motor turning. It's okay. It doesn't need a kickstart, but well, who cares? So let's stop it again. Okay, let's remove the wires. There are a lot of people walking around here. It's a bit annoying maybe, but oh well. Okay, so what did I explain? The power for the Raspberry Pi, the power for the DC motor, and the servo is here, which is for steering, and of course the Raspberry Pi itself. And this has a DC motor head on it, and I have a servo motor head for the servo motor, and the servo motor is going to be attached to the Arduino as well. Okay, what should I do first? Well, maybe also add the other motor, so we have two motors. I think we have the other few. How does this work? Yeah, so my friend left. Lovely. Jeez, of course. Let's see. Bam? No. Bam? No. How does it work? No. Oh man, I don't know how it works. Aha, great. Okay, so I'm going to attach the second motor, the servo motor, through here, and like that. I think it will be good enough. Oof. It's quite far away actually. Let's see. I think it will not be long enough. So how should I fix this problem? This was not happening before. Maybe. Why is this happening to me? Okay. Huh. Okay, this is a nice problem. This was not the last time we did it, but so apparently, as you can see, it just barely gets there, which is not good enough, I think. Last time it was perfect. Yeah, I think it's really too short now at the moment. So what's different this time? I think we probably put these things. Yes, it's turned. So I'm going to blame Pedro on this one. So he actually got this one the wrong way, so it should be like that. Let's see if it can be done. Yeah, where's the tool? Oh, over there. So let's disassemble the front like that. Okay, and the other one. Okay. Okay, let's turn it around. So let's see if we can. Okay, then it should be like this, right? No. Okay, let's get the right distance. Let's see what's just in my way. Yes, okay, so I was just watching the stream. Well, hello back again. So okay, I'm going to add this motor, but I had a problem that this one could not reach this. And I don't know why. So maybe something was switched and now I have to debug it, which is really annoying because Pedro is not here and he should be the one responsible for this. I'm getting very emotional, as you can tell. Okay, so now I have to make it possible to get closer. How does it? Yes, is this working? Oh yes, this is great. Aha. Is it? Or isn't it? No, actually doubting it. No, it's not great still. Okay, okay. Okay. Did also Pedro also disassemble this one? I thought he just kept it in one piece. But it doesn't match anymore. So this one should actually be like that. But the holes don't align. Okay, maybe I should turn it. Right. Okay. Is this the right hole? Is this the right hole? Right. Ja, dat is het idee. Gewoon een beetje voor onszelf. En ja, we proberen het ook met Twitch op te nemen. Want het leek ons leuk om een ding op te bouwen. En om te oefenen vooral. Dus alleen de vriend van me heeft dit in elkaar gezet. Alleen hij is nu net weg, alleen het past net niet. Heeft hij me verlaten. Ja. Even kijken hoor. Ja, dus we hebben hier zo'n DC-motor hier aan zitten. En nu wil ik dus deze motor hier aan hebben. Alleen het gaatje redt het nu niet meer. En ik vraag me af waarom. Maar goed. Dus even een beetje aan het proberen van wat er allemaal mis is.
Ja.
Maar dat is wel grappig. Ja, dank je. Okay, so yeah, like I said, people are walking around here, so which also makes it a little bit less comfortable for me. Well, I think I have to do with it. Okay. Okay. How do I going to fix this? It's really annoying. Okay. What if I would do it like that? Is it even possible? Let's try it. Maybe it will solve my problem. Okay, let's see if this would work. If I would add it like that. Well, it's kind of a problem. So when I added this one,
You removed it.
yeah, I removed it because if I added this one and then this one here, it actually could not reach the hole anymore. So something is different this time than last time. And I don't know what. Do you have an idea?
Yeah, the holes. We drilled extra holes there.
Ah, yes, you're totally right.
Yeah. Where are they?
That's so true. So we...
Here.
Damn, that's the thing, yeah. Okay, we drilled extra holes.
Well, yeah. So that could be a problem.
So okay, well, I think we have to then to add this one there, and then we... It sucks, but it's possible. So I think we have to remove this one, right, then? And
Yeah,
put it there.
remove this one.
Yeah.
And make tube.
Yeah.
Make it out of tube. But then, well, we have enough for it.
You want to do it?
Hmm?
Do you want to do it?
Well, I'm talking to the guy over here, so
Okay.
yeah, you can take care of it. I'll
Okay, so...
sorry.
Okay, well, bye. Okay, so okay, let's see. So I have to totally disassemble it, so that's lovely. Oh, great, all the work of Pedro and I have to disassemble it. So the problem is, I couldn't fix it, and it's because we also added some extra additional holes here. If you can see it, it's here. Come on, here. Let's see if you can see it. Yeah. There's an extra hole and we need that one, so I have to actually disassemble it and put this one over there, which is really annoying, but oh well. I think that's a life lesson. Know where you drilled your holes before assembly, and wise lesson. Yeah, so yeah, okay. Let's disassemble it. Like that, okay. Oh jeez, this is so much work. Really annoying. And in theory we're almost done, just adding the electronics, but no, of course not. Of course there was a mistake. Of course we have to do everything again. How lovely. How lovely. Okay. So remove this one. Okay. Okay, let's also remove this one over here. So indeed we're going to disassemble everything and then we're going to rebuild it again. Woohoo! Lovely, happy days. Okay. Okay, almost there I guess. 2 more of this one and then we can actually start assembling it again. Okay. Okay. So the other one is a little bit more feisty, but we will conquer this one as well. Okay, yes, great, it's loose, nice, okay. Okay, so maybe now we can see it better. Like that. So as you can see, we have one more hole over there. Here, a small one, and we actually need it for the motor, and we totally forgot about that one. So yeah, let's place another one over here. Oh, there's so many people walking around here. Very nice, very nice. We were like thinking, let's stream at night because nobody will be here. But we were wrong. What are they doing actually? Do they have a course or something? I have no idea. What would you do on Friday evening in a industrial, what is it, place? I don't know. Like a lot of companies over here, a lot of startups, scale ups, all tech related. And now I have to tighten everything up again, the whole shebang. Oh man. Okay, the other one over there. Like that. Okay, so we had a small misfortune, so we had to disassemble parts of the RC car, and now I'm going to assemble parts of it again before we can continue adding the electronics. Like that. So this is the back end of the RC car, where we have the DC motor. Like that. Okay, let's just put everything in place first before we're going to tidy everything up. Just because it's more convenient. Okay. Okay, so now I have to think about the holes. Can we turn it? I think we can turn it. Okay. I hope we have enough screws actually. That might also be a problem. So what I'm going to do is effectively make one which is as long as this one, but with the right holes for the servo motor. Okay. Yes, tidying it up. This one we can already tie it up. Great. Yes, lovely. Okay, so now we have this one with the holes. Let's just put it in the right direction. Oof. I think I also have to put these ones at the other side. Okay, take 3 for this part, or I have to put the screws at the other side because it would interfere with the battery pack, and we don't want that, don't we? Do we? Like that. Yes, indeed, we have to watch the holes. Indeed, the holes have been so much, have given us so much problems this time. A bit annoying. Okay. Almost there. Like that. Yeah, last time we also had problems with the holes. Ah, those damn holes. Okay. Okay, cool. Now it should be correct. Okay. Adding 2 additional screws. Let's see. There. Let's add this one over here. An additional screw. Do we also need a spacer? No, we did not use a spacer, so it should be fine. Okay. Let's attach this one. Okay, like that. So, and now the other one. Like that. I know we have done this already, but we have to do it again. Screw, another screw. Screw it again. Let's put a spacer first. And then the screw. I hope we have enough screws now, but I think we do. Oh wait, I think Pedro also added another spacer here. Never enough spacers, I guess. Yes, indeed, the music is very nice. I don't hear it at the moment. I can't hear the music, but I know it's good. What I also know is that there are a lot of people here, so I'm just listening to the ambient sound of people talking. Okay. Let's tie it up. And I was actually meant for electronics, but no. Maybe I should make it a wine stream. Maybe it has its own charms. Hey, he also added a spacer. Oh shoot, do you see this? I probably don't, but... yeah, well, fuck it. It just works. Okay, I need a bigger screw now. Here. Okay, almost again at the same position where I should have started. Okay. Okay. Oh yes, maybe also just switch the cameras. I think it would be good. Like that. So now you can see better what I'm doing. So I'm almost done with the chassis, or with redoing this chassis, because we had a little bit of mistake going on before. Let's add another bolt there. Nice, lovely. So yes, where should this go? That should go there. Let's force it a little bit. Lovely. Okay. So this plateau is actually meant for the Raspberry Pi, because we're going to use the Raspberry Pi to control the DC car. Okay, I think we're almost there again. And now first let's also just see if the steering mechanism does actually fit on the right location. So if we would add this one here. Where are the bolts? There are the bolts. Let's add a little nice lovely bolt. A nice little bolt over there. Bob Ross would probably say it way better than I would. And I do. Okay, and then add another one over there. Like that. Do you have a Bob Ross emoticon? I didn't know that. But I mean, why wouldn't you, right? Because Bob Ross is of course legendary. Okay. Great. Add this one over there. It's probably less tight and less time, but I don't bother with it. Because I just want to get the electronics working. Because I like to do that way more than this stuff. I mean, electronics are the brain of the car, right? The rest is just... yeah, what is the rest? Okay, I think it's fine. The bolts. This one is not nice. Let's see, is it crooked? The bolt? Let's see. Wow, I think it's fine. Okay, let's tighten this one up, and then I think we're done with the mechanical part, the chassis. Okay. Okay, let's get the screw or the bolt and tighten the screw. Okay. Okay, I think I'm happy. Are you happy? Yeah, Bob Ross is amazing, right? Just imagine if Bob Ross would also make robots. I mean, how great would that be? Let's see. Let's tighten this a little bit more. Okay, so I think this will be it. Okay, so where did we left off? Oh yeah, we want to add this one to the freaking steering mechanism. That was the whole idea. Okay, it's a little bit crooked. Let's just use some brute force to correct the position. I can't look at this. Now it does fit. Because we have the correct holes in place. Oh, this is so satisfying. However, I used 2 screws which I actually needed, so I have to get some other screws. Hold on a second. Here I'm back. Okay, so now I have new screws. I think I should open this one. We don't have a scissor, which is really annoying. Ah, fuck it, I think a saw will also work. If you don't have scissors, you can just always saw it. Ah, it works perfectly. Okay. Now we have nice amount of bolts and screws. So let's add a screw, as you can see it. 2 screws over there and 1 screw here. So let's just do it. Okay, let's screw it in because the metal is already like a little bit tight for this screw because we drilled these holes ourselves. Well, a friend of ours did. Where are you? There are you. There you are. Okay. Let's screw this one in as well. Lovely. Lovely. Okay. So it's almost in position, the steering mechanism. And then we can actually do the electronics. Wat? Niet deze? Welke? Die net. Oké. So let's add the last one over there. Right. Okay. Okay, let's insert the bolt. I think it's less bolt for today. Let's hope it's less bolt for today. Okay, cool. So now I have a nice servo motor, a nice DC motor, and of course we need to control it, and we're going to use the Raspberry Pi for that. And let's see. Wait, I have to sneeze. Wait. Okay, let's continue. So we're going to use the Raspberry Pi and also batteries, of course. So what should I attach first? I think I should do the batteries on the bottom. I don't know, it looks kind of aluminium-ish, so I think I will also add some cardboard just to protect it from electricity shortcuts. I think it will actually not happen, but well, you never know. Let's add some duct tape, because duct tape is always your best friend. Duct tape's over here. What?
Did you fix it?
Oh yeah. So now it actually works.
Okay.
So the problem was that these holes were not here, so we had to totally give it a renovation.
Yeah.
Oh well.
Yeah.
Let's isolate this one.
Yeah, we have it here. Deze ding. We hebben het gekocht bij de gamma.
Okay. So let's add the other one over there. So we have a nice little battery sandwich. I would not recommend you to eat it because it's probably pretty deadly, but oh well. It's great and healthy for a robot or machine. In this case, an RC car. So now I have the battery enclosed in cardboard. So I will just put it on top. And the batteries for the DC motor, I already told you before, but maybe you don't. Maybe you just joined in. We use 4 different batteries for the DC motor, and it's actually an 8-pack. So I just made a short wire here, so it's effectively just a 4-pack. And the battery is going beneath this thing here. So let's just insert it. Nice and lovely. So like that. Okay. I think I should put a little bit higher, or else the battery cannot go beneath. I think this one is fine. Okay, I'm also going to move it a little bit to the side, so as you can see there's one battery here. That's because I don't have a off switch, so I'm just going to remove the battery in order to turn it off. It actually works pretty well. Okay, it's still too high, so I have to remove this screw as well a little bit. Okay, I think this is nice. Okay, let's also add a small tape over here in order to make the battery pack in the right position. Add the other battery on top, which is meant for the Raspberry Pi, like that. Okay, lovely. So now we have everything in place, like electronics wise. So now add the brain, which is Raspberry Pi, and with a motor head. So how do I going to attach this, which would be good question, because I also forgot. So of course it needs power. Aha, and we use a USB cable for that. This is a nice small USB cable. I'm going to add that to the Raspberry Pi. So I'm going to use the battery pack, which you can see here. It has, if you can see it, it has USB. So insert this one and add the power to the Raspberry Pi. Where is the... there it is. So here... Okay, so now the Raspberry Pi has power. Well, if I turn on the battery anyways, because it has a nice little button over here. Okay, so now also add some tape to fix the Raspberry Pi on top. So, okay. Great. So the Raspberry Pi is also like firmly in place. What can go wrong with duct tape? So now I also have to add the stepper motor head. So we have, servo motor head. So this is the head which I'm going to use for the the DC motor, and this is the head I'm going to use for the servo motor. So I already have these nice wires with the correct color scheme. So now I'm just connecting the correct colors. So the colors, I think, if you look at the board, it's one is for the ground, of course, which is the mint color. One is for SCL, which I think the data channel, and also GDA, which I think also for data or something. And I also have the positive power, which is 5 volt in this case. So I'm going to connect those. Great, such that I have 2 active heads, or head-like things, I don't know. Okay, I also have to duct tape this somewhere. Let's do it on front. So let's put it here, just because why not? Add a little bit of duct tape. Like that. Also add the duct tape first. Let's add the edge over here. Let's add this one over there. Okay. So I also have to add, so now I have the servo head attached on front of the RC car, and now I'm going to add the wire. I hope I do it the correct way. I always mess it up, so if it doesn't work, well, whatever. I can just turn it around. It doesn't fry anything, so it's okay. Now I also have to add the battery. So this is the battery pack of 6 batteries. I'm going to add that to the motor head. So let's add this one. This is the red wire. Yes. So the red wire is the plus, if I'm correct. Yes, the red one is the plus. So the plus should go in the plus of the motor head. Let's add a screwdriver. Here's a screwdriver. Tighten it up a little bit. Like that. Yes, it's in place. And now the other one. I also actually added some tape at the tips before, and that's because I don't want to have short circuits accidentally of the batteries. So I always put tape if I'm not using the battery pack. Okay, as you can see, there's also a light turning up. Let's see if you can see it. It's orientated. Where's the light? So here's the light. You can see it. Can you see the light? No, it's very non-visible, but it's a green light over there. I think you could just see it. Okay, so now everything is on, attached. Okay.
This one's a bit...
Yeah, well, whatever. It's fine. Let's also just add tape here. I think then we are actually finished with everything, and we can actually add a program like that.
Duct tape. Woo.
Yeah.
Everything you can fix with duct tape. Woo.
I've also watched the show a lot when I was younger. Okay. And then also I'm just tidying up the wires just to make it a little bit more neat. So now everything is attached, so the Raspberry Pi with the batteries and the motors. So I have a loose wire over here. Where should it go? What's a nice location for this wire? Okay, it's a, what is it? A 5 volt. I think yes, I need it for the servo motor. So servo motor had to go like there.
Disney lawyers incoming.
Is she back?
I guess, yeah.
Ah, nice. I thought she was gone for a little while. Okay, so now just tighten up the screw a little bit. Lovely. Okay, yes. Okay. Okay, I think everything is in place now. So what we're now going to do is add the program. It's actually written by ourselves. We're still kind of developing a platform in order to control our C-cars like this and other robots. So I'm mostly robots. Let's first just turn on the Raspberry Pi and see if I got live. Haha, there's live. As you can see, well, you probably can't. Well, maybe let's just use the other camera. As you can
see the lights?
Here. Here you see the red light and a green light blinking, so it means that the Raspberry Pi is booting up. So, oh yeah, shoot, I think I probably need to add a HDMI cable and a screen, because I don't know the IP address. So what I'm going to do is to connect my laptop with the Raspberry Pi, but I actually need to know the IP address. I can't see if it's the same IP address as last time, but it's a gamble. Let's see, which IP address did the Raspberry Pi have last time? Because I'm going to use something called SSH. I don't know if people know it, but it's like a protocol to communicate between different machines. Where's the IP address? Here. Okay, apparently the IP address is different from last time, so I have to turn off the Raspberry Pi again. Bye bye. And I have to.
Can I hook up the screen?
Yeah, sure, thanks. So I have to attach a screen in order to get the. Like that. Okay, that's attached. So can you also give me a USB cable? Yeah, thank you. So, okay, let's attach the HDMI screen, or just normal screen. I think it's a LED screen. Can you put this one in the power? What a hassle just to get an IP address, right? Some people also use a small screen just to post the IP address. So what I'm going to do, I'm going to turn on the Raspberry Pi. Is it correct? Yes, you can also see the screen light on. How lovely. And what I'm going to do, maybe I should just put the screen over there that people also can see the screen. So it's booting. I actually messed up this Raspberry Pi a little bit, so it's actually taking 2 minutes to just load. I didn't really have time or feel the pressure to fix the problem because I didn't care enough. Okay, let's see. I have here loose cables. Yeah, let's. It's never good to have loose cables without some isolation because I don't want to have short circuit. So let's just put some duct tape on the end. Here's my trustworthy duct tape. So these loose cables are actually from the motor head, so they only should give a positive voltage when the motors are ordered to move. So I'm in no danger at the moment, but well, you never know. Always duct tape. I love duct tape. Duct tape is a very nice tool. So here, and okay, great. So let's see what it says. So if you can see it, it's just counting down till a number. It has 30 seconds left before the Raspberry Pi is actually booting up. I think it just likes the suspense. Okay, I have a keyboard, and I think I also need a mouse. Can you give me my mouse? It's somewhere. I'm very... I think yes, a mouse. Good, thank you. Okay. So let's also add a mouse to the mixture. Like that. Okay. So now I have a keyboard and a mouse just to control the Raspberry Pi, which is on top. And we have a nice little screen. And I just only want to have the IP address. That's the only thing I need to do. What a hassle. What a hassle. Okay, yes, it put it up. Okay, let's just to be sure, let's see if it actually was not. No, yeah. So I have no connection with my laptop at the moment, and I want to have the IP address. Let's do it like that. So I'm going to watch the stream just to see what I'm doing on my Raspberry Pi. Okay. Oh man, this is. Oh yeah, okay, wait, the motor is getting mad. Let's just kill. Yes. Kill. No. Okay, come on, don't make a noise. Jeez. The servo motor is really mad. And let's just have, okay, let's also just tape these wires over here. So there's no program running, and apparently it always gives a signal to the servo motors, and I don't know why. Okay, I did have it correctly attached, right? Yes, so blue and the blue, and the mint to the mint. Yeah, it's making a lot of noise, so let's just... Okay, let's do like that. So for some reason always just gives a signal to the servo, I don't know why. But if I just just remove one of the cables, it's fine. Okay, so now continue with my quest to get the IP address. I'm going to open the terminal. This is the terminal. It looks kind of hackery, I know. It looks nice. Way better than, of course.
Talk about your desktop.
Huh?
Your desktop wallpaper.
Ah, yeah. What's the default one? Hi. Ah, man, I want to keep it stable. Are you stable?
Okay, I'm gonna print a thing for that screen.
Well, I mean,
a mount so it can stand.
So okay, it's the thing, and okay. Let's just get the IP address. I think it's for it's Linux, and I think it's called ifconfig, and then it gives a list, and one of those things is my IP address. Yes, I have my IP address now. Ah, lovely. And it is ending on. So I'm using the Wi-Fi here, the local network. So I have to only get the IP address of the local network, and it ends with 172. Okay, so now I do it. Yes, and my laptop does recognize a other machine at the end. So add my password of my Raspberry Pi.
Well, password's on screen.
Okay, so here's my laptop, by the way. Can you see it?
Hacks.
So now I have here the nice terminal. So this is kind of lovely. Now I have a laptop having filming another laptop. So this is now the terminal of my Ubuntu laptop. having a SSL of SSH connection with my Raspberry Pi, and now I'm going to turn on the program which should be able to allow us to control the robot. So let's just do that. I think it's fine, right?
That's fine. That's fine.
Okay. Okay. I'm in, so let's go to the right folder. It's very sexy, of course, to just turning on a program. Very exciting. Okay. Like that. Yes. Okay. And I have an error. Why do I have an error? Oh yes, I know why I have an error. I have an error because it does not see the nice head, so I have to remove this. So my program asks the address of the servo head, but I of course remove the cable of the servo head, so there is no servo head present on the Raspberry Pi. So let's now do it again. Yes, and it works lovely. Okay, so now I turned on a Python program which I wrote, and it allows us to send commands of my mobile phone to the Raspberry Pi and to make it turn. Okay. Yes, so I think we can also remove the screen now because we only needed the IP address. Bye bye. Let's also watch if you guys said something in the meantime. What else? The wallpaper, yeah.
Laptops. We like laptops.
Yeah. Okay, so let's remove all the cables because it wants to run free, of course. It doesn't like boundaries of cables. Okay, so. Okay. What else do we need? So, yeah, the program is running, and I think I have here some loose cables, and that's because the loose cables should be attached to the DC motor. So as you can see here, we have the DC motor, and we have two cables here of the motor head, and we should attach these to the motor. And I'm also going to use duct tape for that, because I use duct tape for everything, to attach everything to anything, because that's how we roll.
We need to make some kind of thing for it.
For what?
For the motors, we need to figure something out.
Nah, I really love duct tape.
Yep.
I mean, duct tape, it's just so good for your life. Okay. Like that. Okay. And the cables are attached to the from the battery or from the motor head to the DC motor now. So I think we should try to actually make those wheels spin, right? Where's my mobile phone?
I don't know. Oh, here.
Okay.
Mine's being used as camera, so you can.
Ah, yeah. Maybe I can also use my laptop for it. So here's my laptop. Let's just rotate a little bit.
Which way are you gonna go?
What? Oh, I don't know. I'm just first. I think I will lift the wheel when I try to spin it. Okay. Here you go. Lovely. Okay, let's try. So, okay.
Don't hold it there. It's gonna.
What? No, it's
no,
here.
Your finger.
Oh yeah, you're totally right. Yeah, okay. Let's hold it like this, I guess.
Shall I do it? Oh, it's not working. I can do the thing.
Oh wait. First, I'm going to add another duct tape because there's not enough duct tape.
He was gonna grind his fingers down.
Yeah. You're totally right. Okay, more duct tape here. Okay, loose wires. I don't like loose wires. Okay, can you? So maybe if you guys can see, maybe we can also just put the screen. So here's a nice little website we made. So here you can see 4 lovely buttons, and you can actually press them.
Press it?
Oh yeah, press them. Press the one going front. In theory, did you do it?
Yeah, I did it.
Okay, that's because probably. No, it's because something is not working. So what is it? Ooh, exciting! Something is not working. Ah, yes, I know what it is. Probably, I think I attached the wrong wires. Let's just put it off, just in case. Turn it off. Turn it off. There only, I mean, there was like 1 or 2 chances I got the right wires, so yeah. Okay. Like that. Like that. Okay. Let's hope these ones do work, or else I have to start debugging. That's the problem of doing everything online, that you will be surprised. And I don't like surprises this way. Okay. Add the duct tape in place. Add the other one, and let's see if something's going on. No. So apparently it was not the wires. So now I have to think. Oh wait. Of course I have to push this button. Interesting. Interesting.
You could. Maybe it's too tight.
Wait, there's also a problem.
Is there?
There's a problem. I don't know what.
Maybe it's mechanical. Maybe it's too tight.
No, I think the program. So I think it's the program. It's having a problem. What is it? What is it? Oh wait. No, it's not. Oh no. It's always nice to have a live debugging session. Okay, so where did I put? Let's see where they are. There you go. No, this one. Okay, let's. Where did I put my Raspberry Pi terminal? Here it is. Ah, yes. Okay, I see the problem. It's not the wires. The program had some issues. So let's do it again. So something went wrong in my program, and that happens a lot of times. So it's not a big issue. Okay, now the debugging starts. I know the problem. I know the problem. I had it already before, but okay, I have to change the name of my program. Let's see. Yes. It will take a short while, not that long. No worries. Let's see. Where did I put my file? So we actually did the programming before we did the stream, because programming can be quite a bit boring when you do it online. But well, if you have a problem, you have to just do programming on the spot, I guess. Where did I put my code? It's over there. It's there. Great. Now I'm getting annoyed. Okay, cool, cool, cool. Okay. Something went wrong during updating. Ways. Yes. Okay, now it's going. Yes. Okay, let's try it again. Exciting. What will it do? What?
Could be some alignment issue.
Oh yeah. Okay. I think we have live. Okay, good, 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 good. Yes. So
Spin it.
now the problem is solved. Okay, let's go back to the controller to reload it. Lovely. Yes, there you are. Okay, okay, okay. It's done. Okay, let's try to spin it. Let's see if it works. Did it move?
No.
Oh wait.
Oh.
Yeah? Yes. Okay, so why it did spin before. So I think still the maybe it could be that.
Yeah, I think it's what do you call it? Some alignment issue. Yeah,
I didn't.
I think I know what it is.
What is it?
It's too low. Yeah.
Well, I mean, it did spin before, so.
You gotta take these off, put them under.
I mean, that should not be the problem, right?
I don't know.
So you think, but I mean, if you just lift it up, it doesn't really matter. So I think it's just the ratio again, still.
I based the ratio off.
Okay, maybe because also there's not enough power. So let's just add some power. Maybe that would work.
Okay.
So let's just first. Okay, now
the
we're
ratio
going
off
to do hardware debugging. First we did some software debugging. Now we have to do some hardware debugging. Oh, life is so splendid. Okay, so what I'm going to do is just attach it directly to the battery pack.
Really?
Yeah. So.
Okay, so then it's a power ratio problem. Because I based the ratio on an RC on another.
Okay,
RC
if I do directly, so maybe it has enough power. Let's check. Okay, let's first also just add some tapes again before I get short circuit. Not enough duct tape, never enough duct tape. So maybe I'm going to add some additional batteries. But I have to think if I'm not going to destroy the servo motor, which would be bad. Okay, let's try. So it does spin, but yeah, it's not strong enough. So what will happen if I add another battery? I hope I will not destroy the motor, by the way. I can also just check if
the ratio is fine because I researched the ratio.
Yeah, so it could also be the battery. Now I have to remove the battery pack. Oh, they will be annoying. So annoying.
If it doesn't work, then there's something weird going on.
Well, I think it's the battery pack. It's probably not having enough power. So I'm going to remove it. Okay, let's remove the battery pack. Okay, let's do this like that. So if I do this, okay, let's come on, duct tape. You're only temporary. Let's just use duct tape before continuing. So I think also the motor needs. I think the voltage or the voltage is correct according to the specs of the motor, but I think it needs more ampere, more power. Come on! I don't have scissors. It's really annoying. Where's the saw? I had the saw, right? Yes, thank you. So if you don't have scissors, always use a saw. I mean, Boo has scissors these days. I always do everything with a saw. Okay, lovely. Okay. So now I directly attached it to this thing, so as you can see it does spin if I give the little kickstart. But it doesn't really spin very hard. It might be because let's just check the power, the status of the battery. Well, this is good enough. So if you can see, oh man, where's the point? So if you can see, if I push it, you see red and yellow. So this one is okay. It's not perfect, but it's okay.
So what's the ratio?
Should
it be the ratio? I researched the ratio.
No, I think it's. It might be just the power. Let's see what does this one say. It's okay. It's okay. Not perfect. And this one also still okay. They're all kind of red, yellowish. Maybe that is a problem.
You add new ones?
I also have another battery set, so let's just add some other ones. Actually, maybe I also didn't add enough batteries. So now I have 1, 2, 3, 4 batteries, which is 6 volts. Do you know which voltage I had to apply to the battery, to the motor? Do you know that out of your head?
7.5 was it?
Was it 7.5? If that's true, then I actually didn't add enough batteries, and that would explain a lot. So let's just remove this one. I think you're right. So maybe that's the whole thing.
Wasn't it 7.5? Let me check that out.
Well, it does. It's already better, but still not enough power. It is spinning, but it's not having enough power. So when I release it on the ground, it's not doing anything. Wait. Let's check. Yeah, it's
7.2, 7.4.
Oh yes, so I needed one extra additional battery, so I added that one. So now it should actually be fine.
Oh, I thought you. I didn't even pay attention to that.
Yeah, well, apparently I didn't do either. So now we have enough batteries.
Whoops.
Oh. Okay, so let's see the voltage of this battery pack now. So it should be 7.4, you said, or something?
7.2 to 7.4 is the range.
Okay, so now let's see what we have here. It's... Oh, you cannot see it, so that's that right here. So the battery range is now... Come on.
10? What was it?
Yeah, well, I mean, that should not be right. It's not a lot. Why is it 1 volt? That would be true. Come on, what's the problem? Is it because it's attached to the motor that... Ah, yes, maybe that's true. Yeah, I think you cannot calculate the voltage when it's...
It's too much...
I have actually no idea. That's true. Okay, so that's not the case. Let's see. Okay, this is attached over there. Attached over there. Oh yes, I got it. I'm stupid, that's the thing. Okay, so I should actually measure it here. And yes.
6. You need one more battery, man. Add one more battery.
So wait, 6 doesn't make sense, right? 1, 2, 3, 4, 5. 5 times
1.5.
yeah. 1.5, right? Yeah. So that is 7.5. So apparently the batteries are fucked up or something.
Change batteries.
Or I'm not measuring it right now. I know that should be fine. Okay, let's see if I measure it here. Here and there. Okay, let's just add another battery then. I think they're just so old that they're not having the right voltage anymore.
More batteries.
Okay, an additional battery. Let's go crazy. So actually it should be too much, but apparently the batteries are too empty or something, so we actually need another one. Another one, why it's too dust. Okay.
Another one.
Another one. Okay. And let's measure the voltage right now and let's see what we get. So now we have too much. Is it bad?
I don't know. You gonna fry it?
Will we die? It's 8, so it should be 7.2, right?
7.4.
Just for fun, just see what
7.4.
happens. Wait. Let's start here and let's see if it actually works. 7.4, right? Yeah, max. Yeah. So let's just.
What's worse that can happen?
Well, kill the motor. Let's see.
My surprise face. Oh my god.
It does work. But I think we should not do it for too long. Maybe I don't want to kill the servo mode as well. It's a surprise phase indeed. So what's the problem? Let's see which battery is the worst. Which battery? What are you? You're fine. What is the other battery? You're fine as well. So let's just remove. I think we should not go for 8 volts. I think we will really fry the motor, right?
So what are you gonna do?
Cry. I guess.
Yeah, it does look like it.
No, I think the batteries are all fine actually. I think I just pressed it wrong. So, okay. Do you think it would be wise to go for 8 volts?
No. Whatever. Leave it.
I just want to see if it actually can move with 8 volts. It can move, right?
Chat says do it.
No, I smell something. Okay, so I think this will be it for now, right? I mean, we cannot make it move, and I think I start to smell something if I use the 8 battery thing.
Don't do it.
No. Okay, so I think we'll just keep it like that. Oh man. So what do you think we should change next time? Because, okay, let's just for fun remove this thing.
Put this down there.
Let's just remove this one. So if you would just remove it, then you should probably see it move very fast. Can you hear it? And you can see it? So it actually does work, the motor. It should just go that fast when we have enough power. But I think... So, do you think we should change the ratio or something?
No, the ratio, man, I based this ratio on a gearbox from another. I copied the ratio exactly, so it should work.
Yeah, so...
real quick, put this one under instead of...
That would not make the difference. I mean, it's not...
Try it.
No.
What else you got to lose?
Time. I mean, it works fine. I mean, if you also just... If you bend the metal bit, it's already... I already did that, and it didn't do anything. So, because you think... probably that if you... Let's just remove this one. No, let's also just remove the battery. So, if we...
Bend it.
Because, no, I mean, it fits really well. So I think it's no problem, right? And it's also like really smooth. Is it smooth? Let's see. Maybe this is the problem. It's also, this is quite tough.
What stuff?
If you just rotate it.
Gotta bend it more down.
Yeah, but how? Maybe like that.
No, down.
I think it's rotate, right? Now this is better.
That's it.
Wait. It's better?
No,
Or this?
it's better. You thinking it's crooked?
Yeah, maybe. It's not aligned. I think. But oh, maybe it's also the motor, right? Because it's resting on it.
Well,
Which you probably did not use the damage, so no.
The damage? What?
We also have a damaged bearing, but I think you did not use that one.
No.
So okay, so there's a lot of resistance. Do you think that will be the main problem?
Yeah, that's probably it. I mean this is not it's about a millimeter offset. So you need to either twist it or
I think we should just debug it for next time.
sure, but let me just get that there. That there.
It's way better. This is way better.
Yeah, let's see. Oh, wrong way. Go there. Move it in.
It's way better.
Yeah, but the thing's not aligned now. And then yeah, I know what the problem is.
Okay, this is now a problem. And this one is not attached.
Yeah, I know. So now.
So why was it? It looks already way better by resistance rise, right?
Yeah.
Okay, so now you have to tighten those things up, right? It's fine, right? It doesn't skip.
Yeah.
So it's fine, right? So, but now we should of course tighten up the things.
Tighten it there. Grab it there.
And then,
No, tighten.
oh, which one? It should go down, right? Yeah. Yes.
Okay.
Is it good?
Yeah, it's good.
Okay, let's
Okay, try it.
just see if the resistance does help at least. Oh, that's also at the battery, right?
Oh.
It does move, but still not significantly. Ah, it does move.
Shit.
It does move. But this is of course with 8 volts, and I think we should not do that.
Shit, 8 volt?
Yeah, so let's just remove that battery. And let's go back to too low. I mean, this is too low, right? So maybe we should have a better power supply, which can actually give the right amount.
Yep.
Because these batteries are really fucked up sometimes, apparently. Okay, let's add a little bit of...
Yeet.
Is it the new, our, how you call it, mascot?
I guess.
Okay. So,
Oh shit.
it does actually work. Just for fun. Because...
Yeah, it was resistance. It was stuck too far now.
Yeah, okay. Should he try again? Let's
Sure.
put this one in. Whatever, fuck it, it's good enough. Now I have to put the wires in the correct position again. So the red is plus, right? Yes, the red is plus. Right, the red is plus. Add it here. And tighten it up. And now the other one, the minus. Let's add this one here. Okay, so now add the control wires. Looks like a ghost. Ooh, okay.
Okay.
Oh yeah, we didn't do it, right?
Do
Okay.
it.
Let's see.
Watch those cables.
What?
Cables by the wheel.
Yes, but why it's not doing anything? the head. Let's see. The head is not having any power. What's the problem? Okay, hello head. What's your problem? So I have the plus. I think I might have interchanged the plus and minus then. Let's see. Yes, I most definitely changed the plus and minus. No, I have already done that before and apparently it doesn't break, so that's good. I think it does. I think I have the minus and the plus interchanged. Lovely, right? Yeah. And was that the problem? Yes, that's the problem.
Really?
Okay, so... Okay. Now I have power again. And... Yes! Okay, let's try. Put this one here. Put this one there. Come on. Don't film me. Like that. Okay, cool. Oh man, it's so hideous. But if I do this, it does turn. And let's put it on the ground. Let's see if I can get it.
Wait! I got a camera on it. Wait for it.
I think the batteries are really empty. Okay, is it correct? Yes. Okay, let's try. So if I go to give the push. Okay, let's go the other way. Hold on. Okay. It does kind of work, right?
It stopped spinning.
What?
It stopped spinning.
Yes, but that's because... So let's just... Okay. Wait. I have to do the steering first. Ah yes, the steering. You can see, okay.
No, you can't see.
Yeah, you can see now.
Oh, there.
Okay, so steering is now correct. So let's just give it a... Ah, come on. Okay. Okay, nice. I think we should definitely fix something for next time. And this doesn't go forward, right? But it's not powerful enough yet. No, it's not powerful enough. So maybe we should actually add 2 motors next time.
Well, I don't think we need 2 motors. I'm gonna fix the gearbox next time. Right now it's a bit too weird, and the fix I'm thinking of should solve the issue.
Should I just turn it off?
Put it on the ground and see it.
I mean,
Yeah, fine. Check it out. It does spin.
yeah. It does look nice, right?
Yeah, it works well, but I think, yeah, I'm gonna change it up. I'm gonna leave the ratio, and I'm just gonna print out an extra part to make sure that things stay aligned, and that's it. Also, I think I'm gonna remove one of these.
It can also be that the power is not good enough, the motor.
Maybe.
Maybe the motor is not that strong.
I don't know.
I mean, what if you would have 2 motors?
2 motors? Nah, I don't think 2 motors needed. I think the motor. Oh. It stops.
I would just turn it off, right?
Yeah. Yeah, I know how to, I think I know how to fix this. Oh, also. Oh, this that's kind of.
Yeah, well.
Oh shit! It popped out. No matter.
Okay, so we just call it a day for tonight?
Yeah, sure.
So, well, apparently we didn't succeed in making it work. But well, next time, Okay, so this is attempt number 3. Let's go for attempt number 4 next time.
Sure, man, whatever. We're gonna make it work.
Well, my stream, can you?
Yeah.
Okay.
We're gonna go fix this for next week.
Yeah.
And I think the problem is in the gearbox. That it has a bit too much resistance. Because it's dependent too much on the metal strips. I'm gonna fix that for next week. I'm gonna make it its own, because I was thinking of doing that already, but I thought maybe this was enough, but I'm like, but I guess not. So I'm gonna make the gearbox its own unit, like independent of anything, so the distances and everything is like perfectly aligned. I mean, that's what you usually see in RC cars anyways, but I thought maybe we could get away with some whatever, but I guess not. You know, they do it for a reason like that. So, you know, I'm gonna do that, and then it should solve these issues. Yeah, that's the plan for next week, because the distances and all these factors that are messing with it are gonna be eliminated because of that. Yeah.
Well, have a good evening, I guess, or whatever you are. Maybe.
Yeah. Yeah. So, yeah, that's it for the stream, guys. So, we'll see you guys next week then. Bye-bye.
Bye.